Okay, let's take a look at how to determine positive or negative intervals. This again is something we did in topic 1, and we did it graphically. We're going to take a look at it algebraically. Now, we know a graph is positive, or a function is positive, in the places where my y values are greater than 0, which of course is above the x-axis, and it's negative below the x-axis. And what's going to kind of hint us off to where that changes are our x-intercepts. So what we're going to do is we are going to first factor our equation, and then we'll take a look at the intervals it creates and do some testing to see if we get positive or negative values out. So here we go. I'm going to factor this. I have a leading coefficient of 1, which makes things nice and easy. I'm just going to drop my parentheses in, drop the x's in. My c value is negative, so that means my signs are going to be opposite. And now I'm looking for two numbers. When I multiply them, I get the -3, and when I add them, I'm going to get a +2. Well, that's going to be a -3 and a +1. And so when we solve these, you would be setting these equal to 0, each factor equal to 0, to get your x-intercepts. Now, of course, I'm sure that you've probably caught on by now. You really don't even need to show this step. If you just come up here, come into your original factored form here, take your value and just switch the sign. That's all you need to do. So I have x-intercepts at x equals -1 and x equals 3. Now, if you consider this, let's take a look, put this on a number line. This is going to create 3 intervals. So if I have a -1 and a +3, I have 3 separate intervals. I have one here that starts here at -1. It goes in the negative direction all the way to -infinity. And so that's x values that are less than -1. Now in between here, so between -1 and 3, I have another interval, and that's where x is between -1 and +3. And then I also have another interval, my last interval, where my x values are greater than 3. And again, if we continue going off to the right, we are going off to +infinity. So what I want to do is I'm just going to take any x value. It doesn't matter which one you take as long as it's in the interval. I always go for the easiest. You're going to substitute it back into your original equation, and you're going to see, does your y value pop out positive or negative? So on this one, x is less than -1. Well, let's just try x equals -2. Let's test that x value out. So I'm going to substitute x equals -2 in for x. I'm going to get y equals, let's see, I have a -2 squared minus 2 times -2 minus 3. And now we're just going to simplify. -2 squared is 4. -2 times -2 is a +4, and minus 3. So that means y equals 5. And the value isn't really important. What is important is it positive or is it negative? Well, 5 here, that's a +5. So that means any x value that is less than -1 is going to produce a positive y value. Now let's check the second interval. This one's the super simple one. I like it. 0 is between -1 and 3. Makes things really easy. And of course, if you substitute x equals 0 back into this equation, you're going to get y equals 0. Or not, excuse me, not y, because y equals -3. So y, again, I'll just do it. We'll go through it just to keep it consistent. So these all go down to 0. You get y equals -3, and you all know that's your y-intercept. And again, notice this is negative. Again, the value doesn't matter. What matters is the sign. It is negative, so that means any value of x that I put in that's between -1 and 3 is going to produce a y value that is negative. My function will be negative in that interval. X is greater than 3. Let's do x equals 4. So again, substitute it in. Y equals 4 squared minus 2 times 4 minus 3. And that gets me a 16 minus 8 minus 3. And again, the value doesn't matter. What matters is I get a positive answer. In fact, a lot of times when I do these, I don't even carry out the computation all the way. If you can see that you're going to be positive, you don't need to go any further. It's going to be positive. Again, the number doesn't matter. What matters is the sign. So here we are. We have determined that my positive intervals are going to be when x is less than -1 and when x is greater than 3. And of course, you can also see that here's the graph. And in topic 1, we looked at the graph and we said, okay, well, here is where my graph is going to be above the x-axis. It's going to be from -infinity to -1. Well, writing x is less than -1 is just another way to state that. And again, in between these two intercepts, we can see the graph is below the x-axis. So I am negative between -1 and a positive 3. And then when my x values become greater than 3, boom, we are going to be positive. Now, to me, this is a very tedious way to do it. It's very mechanical. Usually I like that, but this is a little bit lengthy for my taste. But again, I would think that with what you know already, you could go ahead and almost think about it doing it graphically. So let's think about it this way. Forget that you even saw that. You didn't see it. So I know my x-intercepts. So if you were just to even sketch in a little graph, and you could just go ahead, put your x-intercepts in there. And if you look at this, knowing what you know about your transformations, it's not negative. This is positive. So that's a positive a value. And if your a value is positive, you know your graph is going to open up. You also know a quadratic looks like a U. So it's going to have to come down. If it's opening up, it's going to come, and it's just going to kind of curve up and go through the other x-intercept. So even just knowing that, you can see that clearly between -1 and 3 is going to be your negative interval. Any x value less than -1 is going to produce positive, and anything greater than 3 is going to produce positive. This to me is the quick, easy. This, of course, is also acceptable. I'm going to leave it up to you what you want to do on your test. You can either sketch it or you can go ahead and test intervals.